More than 100 years ago, Albert Einstein predicted the existence of a phenomenon known as gravitational waves. Just this year, scientists at the Laser Interferometer Gravitational Wave Observatory, or LIGO, confirmed their existence. This discovery signals the start of a new era of astronomy. But what exactly are gravitational waves? They are often described as ripples in the fabric of space-time, which, according to Einstein, are generally caused by massive objects accelerating or catastrophic events such as black holes colliding. To picture the creation of gravitational waves, imagine a large animal like a shark or whale swimming circles in the ocean. The ripples in the water, ocean waves, are kind of like gravitational waves if the water was space-time. Catastrophic events, such as an anvil dropping into the ocean, cause a larger but more temporary wave. So why have we been searching for these gravitational waves anyway? Well, first of all, it would be proof that Einstein was right all along, confirming that our current view of the universe is at least on the right track. But many scientists would argue that it would be more significant if Einstein was wrong, if we definitively prove that gravitational waves don't exist. That would be the most exciting discovery of all, to completely overhaul a century of scientific thought. But since Einstein, like usual, was correct, we are using this discovery to further develop our current model. Most importantly, gravitational waves are not a part of the electromagnetic spectrum, and objects such as black holes do not emit electromagnetic radiation, but they do cause gravitational waves. The ability to detect gravitational waves allows us to gain information about previously unidentifiable bodies. Before LIGO's detection of gravitational waves, there were many unsuccessful attempts. Notably, Joseph Weber invented the first gravitational wave detector, known as a Weber bar, and vehemently defended his supposed detection of gravitational waves. However, most people don't believe him. That doesn't mean Weber had no impact, though. In fact, one of the leading researchers at LIGO, Kip Thorne, called Weber the founding father of this field. More recently, in 2014, researchers at the Harvard-Smithsonian Center for Astrophysics believed they had found evidence of primordial gravitational waves, waves originating from the Big Bang, which would have proved the theory of cosmic inflation. What they thought was cosmic background radiation, however, turned out to be dust. But that all changed in February 2016 when LIGO, based in Hanford, Washington and Livingston, Louisiana, and staffed by researchers from Caltech and MIT, published evidence that they had detected gravitational waves using a laser interferometer, the LI in LIGO. The interferometer works by splitting a laser into two perpendicular beams that shine down two paths. The beams bounce back but cancel each other out in a process called destructive interference before light shines on the detector. If a gravitational wave were to affect the area, however, the waves would squish one leg of the laser and stretch the other. This would result in the lasers going out of the canceling phase and shining a beam on the detector, which would then be picked up by the interferometer. The LIGO observatory, starting in 2002, sat for 8 years without detecting a signal. In 2010, the observatory was shut down for upgrades. It restarted in September of 2015 and began detecting gravitational wave signals the very same month. After verifying the results for a few months, LIGO published their findings in February 2016, all but ensuring their Nobel Prize and changing the way we can see the universe. Special thanks to the LIGO Observatory and the information they provide, MinutePhysics for the inspiration for this video and the rest of our sources. But wait, there's more! We couldn't find a place for this in the rest of our video, but it's super awesome. So here's the actual sound of two black holes colliding.